Good morning, everybody. Welcome to TriStar's Creo Series live webinars. Today's feature is Advanced Part Modeling Techniques. My name is Shawn Schreckengost. I'm a Business Development Manager and Application Engineer with TriStar. TriStar is one of North America's largest resellers of PTC products. And welcome. Thank you for joining us today. For our agenda today, we have about 30 minutes, probably go a little bit longer, to cover some of the advanced part modeling techniques in Creo Parametric. With these advanced techniques, we'll be able to design products more efficiently. We'll learn how to reuse geometry with what's called a user-defined feature, or UDF. And then we'll discuss a little of the techniques around engineering features with auto-rounds, trajectory ribs, drafts, chamfers, and shells. I have just a few slides today. We'll go through them first, and then we'll go straight into a demonstration, and then we'll open up for some questions. So first of all, a user-defined feature, or UDF, enables us to reuse geometry when creating new design models. A UDF consists of selected features, all their associated dimensions, any relations between the features, and a list of references for placing the UDF on various design models. UDFs will save us time by helping us to establish a library of commonly used geometry. So in this section, we're going to talk about or discuss how to create user-defined features to reuse geometry, how to place those user-defined features, and then also creating user-defined features using what's called an on-surface coordinate system. User-defined features are groups of features, references, and dimensions that can be saved for use on future models. We typically define a UDF from a template model. This would be a pristine model that doesn't have very many features, just kind of a base feature to build on. When we define the UDF, we can use a standalone or subordinate option. The standalone says that the UDF is going to be its own entity, and of course we can create a reference part when we use the standalone option. Subordinate would mean that the UDF itself is a subordinate of the template model that we use to create the UDF. When we select features to include, they must be sequential in the model tree. So we cannot skip over features, meaning I couldn't use features 3, 7, and 8. I would have to use features 3 through 8 to create the UDF. When we're using features in the UDF that requires references, we have to define prompts within the UDF to indicate what the user needs to select when placing the UDF. And then we have the option to define variable items, such as elements or dimensions, or even using family tables within the UDF. When we place UDFs, we can save a lot of time when modeling because we're using a library of previously used features. We don't have to redefine the features or recreate the features. What we'll do is we'll open up a UDF to place on the model. We'll select the placement references that are required. If we enter prompts into the UDF when we create it, they can help aid us in placing or selecting those references. We can edit any variable dimensions or annotations, and then we have options for scaling or displaying dimensions or reducing features. And then finally, we can adjust the UDF when placing it by flipping the orientation. And then finally, if we use an on-surface coordinate system to create the UDF, we gain a lot of capability. What we would do is we'd set the UDF to reference only a single on-surface coordinate system. This would make placing the UDF very quick and flexible. All we have to do is select a coordinate system. Okay? If we choose to define the coordinate system during the placement of the UDF, we can then drag the location and the angle of the coordinate system. When we do this, no prompts are required, and we would specify the on-surface coordinate system upon placement. Some of the other features that we're going to discuss today is, first of all, one being the Autoround tool. This enables us to create a complex series of rounds very quickly and easily. These rounds are created as a series of rounds in the feature itself. Afterwards, we can convert the round to a group of standard round features if we wanted to edit them individually. This is a very robust rounding technique. It uses an intelligent order to create the rounds, and if we were to go back in history and add any features to the models, those features would then be included in that Autoround feature. Another feature we'll discuss today is the trajectory rib. This tool allows us to create a network of ribs with options to actually add draft and rounds at the same time. We have to create a sketch for this trajectory rib, but what's nice about this is the sketch actually extends itself to the model, meaning we don't have to actually align the ends of our sketched entities to the model itself, although that will help in reducing the amount of dimensions for the sketch. These sketched entities can self-intersect, meaning the ribs can self-intersect. They can also pass through existing features and have multiple open loops. We also have the option to add drafts and rounds to the trajectory rib. And then finally, we're going to discuss some techniques and best practices for creating drafts, chamfers, and shells. So with that, I'll start my demonstration. And here I have basically my template part for the first simple UDF that I'm going to create. Now with this UDF, we have our base protrusion, which is really not going to be part of the finished product, but it is what I'm building off of to create this boss that you see here. And this boss is comprised of these 7 features that you see in my model tree. So I want to be able to reuse this on multiple parts. Now it's always a good idea that if you do see a series of features that you think would be a good idea to use on other parts, you really shouldn't try to make that UDF from the part that you're in. You should make a template part that's very simple, and when you create the features that you want to use in the UDF, you want to make sure that you use very sound reference selection techniques and also reduce the number of references that you've used in creating the features. The reason being is that every reference that we use in creating these features will have to be re-identified or reselected when we place the UDF in the model that we want to use it in. Okay, so that being said, let's go ahead and create this UDF, and I'll go through each of the steps and describe what I'm doing along the way. The first thing is to go to where we would create the UDF, which is under the Tools tab and the UDF library. When I select on that, I have some options. In this case, I'm going to just use the Create option, and then I'm going to give the UDF a name. So I might call this Boss-1, or maybe something more descriptive, saying the size or whatever would be nice. We want to make sure that we give it a name that people can recognize. Once I've entered the name, I then am prompted to say or choose whether I want to use a subordinate or standalone. Now remember, the subordinate says that the UDF itself is a subordinate of this model here. If I change this model, that UDF gets up, and we really don't want that. So I'm going to use a standalone. Okay? Standalone says that this UDF is going to be its own entity. Okay? We'll say done. And now with this option, I have the choice to include a reference part. What that means is if I choose yes, it's actually going to take a copy of this template and make it a reference part. The reference part will then be available to me when I place the UDF, so that as the prompts appear, I can actually see what I'm supposed to be selecting on the new model. So I'll go ahead and say yes, I want to include a reference part. Now I don't have to use the reference part in the future, but if I don't say yes here, I won't have that available to me. Now it's ready for me to select the features that I want to include in the UDF. Now remember, this needs to be a range of features. Okay, I cannot skip over the features. So in this case, I'm going to select my extrude 2 and then hold my shift key down and select this round 2. So those are all of the features that I want to include in this UDF. And we'll say OK, done, and done. Now it's asking me to enter a prompt for the highlighted surface. So you can see what's highlighted in red on my model. It wants me to enter a prompt so that the users who are replacing this UDF know what they're supposed to do. So my prompt is going to be select the placement plane. I like that. The next surface is the lower surface that you see highlighted in red, and this would be my vertical reference. So I'm going to say select vertical reference. And the next one is the left side of the model being highlighted. That's going to be my horizontal reference. So I'm going to say select horizontal reference. Okay. At this point, I've entered all the prompts for the references that I used to create these features. At this point, it gives me an option to change it if I want. If you'll notice down in the lower left-hand corner of our Pro-E session where our message area is, you'll see that the current prompt for the highlighted surface is select the placement plane. If I hit next, it's going to ask me to select the next reference. Okay? I have a choice now to enter a new prompt if I don't like the prompts that I had entered. But in this case, I'm going to say done. At this point, I've pretty much defined the UDF, but I do have some options. If I wanted to, I can change any of the variable elements, the variable dimensions, the dimension values, the variable parameters, family tables, and so on. But these are all optional, and I don't need to define these. I can always change any of these dimensions after I've placed the UDF, or in some cases, actually change it during the placement. So we'll say OK, and that UDF has now been created. So I'm going to open up another part here that I'm going to use to place UDFs on. And I'll go ahead now, under the Modeling tab, we have User-Defined Feature. And here in my working directory, we can see that that boss-1.gph has been created, and that's really the only UDF in my library at this time. Now you may have, in the future, set up a library of UDFs, and you can actually store that on your hard drive or on a system drive or what have you, and then in your config.pro have a pointer to that folder for your UDFs. So your UDF library can be located anywhere. In this case, I'm just using my working directory. So we'll open this, and here we have some options now to place the user-defined feature. By default, the advanced reference configuration is selected. And that's nice. We can then see what our prompts are and what we need to select. Here's that choice I mentioned earlier for the source model. If I want, I can view that template or the source as I'm placing the UDF. So that's a good idea. And then the other option here is to make the dependent features, make the features dependent on the UDF. I don't want to do this because I want to be able to change them later on. So we'll say OK at this point. And two things happen. Our reference model shows up in a reference window, and then our advanced reference configuration dialog shows up, which includes our prompts that you see here. Select the placement plane, and then a list of the references that I want or need to select. And as you can see, we get a kind of a feature preview in my Creo window. All right, so I'm going to go ahead and just move this over a little bit, and I'm going to select the surface first as the placement plane. And now you'll notice in my reference window, the next surface highlights. And in my dialog for selecting the references, I get my prompt, select vertical reference. So I'm going to go ahead and do that now. And then finally, the third reference is the horizontal reference, and I've got to select the similar reference that's shown in my reference window. So we'll just pick that back surface there, and that should be all we need to place the UDF. Okay. Of course, I have options. I can come in here and scale the UDF. If I want to hide dimensions or lock them so they can't be changed, I can do that here. I can even edit the definition of any of the features in the list. So if I wanted to change the elements of, say, this extrude to change the height on the fly or something like that, I can do that here. What you'll notice down here is that my auto regeneration is checked and my feature has succeeded. Okay. So we'll go ahead and select the green check mark, and there our UDF is been created. Now at this point, it shows up as a group in my tree. I can expand that group and edit the individual features. I can change the height at this point because I didn't make this a subordinate UDF, or a dependent UDF, I should say. So I can make those changes. These features have no associativity back to the original UDF or the original template model. They belong in this model at this time. So I can pretty much do anything I want to these features. I can even ungroup them if I so choose, but I kind of like having groups in my model tree to help me organize. Okay? Now we'll go ahead and use the on-surface coordinate system method of creating a UDF. With this UDF, you'll notice I have a boss. It's similar to the previous boss, but we have two holes here. And in this situation, I might want to be able to change the angle of the UDF as I place it. So this is where the coordinate system comes into play. When we use an on-surface coordinate system, which is what I have here, we'll be able to place this model or this UDF on another model using just the coordinate system, or actually define the coordinate system on the fly. Okay? But you have to be very careful when you're creating the features for this type of a UDF that you only reference the coordinate system. So if we expand on these features, what you'll notice is that I have a lot of internal datum planes. Even my sketching plane was created on the fly through that coordinate system. In that way, I only have the one reference. So be very careful that you know what your references are when you're creating these features, so that we're not using, part datum planes or edges of the surface or things like that that we would then have to reselect when we place the UDF. Okay? So in this case, I'm going to go ahead and go to my Tools menu again. I'm going to create a new UDF. This one we're going to call Boss2, for lack of a better name. Again, you should probably use something that's descriptive of what the UDF is. Again, we're going to use the standalone option. We're going to include the reference part. I'm going to select the range of features. I'll accept that. Done and done. And here you'll notice that we have the coordinate system highlighted, but we have another option here. That coordinate system is used multiple times for these features because I always reference back to that coordinate system. So in this case, since that reference is used multiple times, we could enter a separate prompt for each time it's used. Or in this case, since I really want to have just one pick, I'm going to use single on the prompt and done. And now this just needs me to select a coordinate system to place this UDF. Okay. We'll say OK there. And again, I get the option to change that prompt if I want. If you'll notice in my message bar, it's showing me what the prompt I entered. Do I want to enter a new prompt, or do I just want to keep it? I'm going to say go ahead and keep that one done. And again, I'm now complete with creating this UDF. If I wanted to, I could set some of the optional elements. Again, I like to do that after the fact, so I don't want to mess with it here. So we'll say OK and done. Now I can go ahead back to my placement part, and we can place this UDF. Now this UDF is going to have an additional option when we place it, because of the way I created it, to actually define the coordinate system on the fly if I want to. Or I can just choose to select. So in this case, we'll go to User Defined Feature. We're going to use Boss2. And here's that extra option I was talking about, to create the coordinate system on the fly. In this case, we're going to just place it by selecting a coordinate system first, and then we'll try this method as a second option. So I'll say View the Source Model. I'll use the Advanced Reference Configuration, and I'm going to say OK. The same thing happens where we have the dialog appears. You'll notice there's only one reference that needs to be selected. My prompt is to select a coordinate system. As you can see in my reference window, it's showing me where that coordinate system is relative to the UDF. And I just need to pick a coordinate system, and I'm golden. Let's do that again. User Defined Feature. We'll say Boss2. We'll say Open. I'll say View the Source Model, and we'll say OK. And again, I just need to pick a coordinate system. So very easy to place these because I only have one reference to select. Finally, let's place it again. And this time, we'll use the on-surface coordinate system. Okay? You'll notice that the advanced reference configuration is blanked out as a result, because this is going to require me not to select, but to actually define the coordinate system during the placement operation. So we'll say OK. Here we get our reference window. We really don't need to see that at this point. We've pretty much seen it multiple times already. But now we just need to select the coordinate system, or define the coordinate system, I should say. So in this case, we'll go ahead and just drag this window out to the side since I don't want to see that. I'm going to select the surface that my coordinate system is going to be on. So I'll select this surface right here. And then what type of coordinate system do I want to create? I have the linear option, I have a radial option, and I have a diameter option. Well, let's just use the radial option for this one. In this case, it wants me to select some additional references. I need to select something to rotate about and some angle to measure against. And so in this case, we can rotate the coordinate system. we can rotate the angle from my angular reference or axial reference, and we can put this anywhere on the model at any angle. If I like what I see, that's what we have. So very easy now to place this in basically any position that I want on this model. So that's enough of UDFs. We have a few more features to go through here. The next one I want to talk about is the trajectory rib feature. So I have another model that I want to use. And in this model, we basically have a simple, perhaps plastic injection molded part. In my rib menu, you'll see that we have two options, the traditional profile rib, or we have the new trajectory rib, which has been around for a couple of versions of Creo, and I think even Wildfire 5, maybe even further back than that. But it's relatively new to the suite of tools that we have in the modeling environment. When I create a trajectory rib, I need to select or create a sketch. And that would define the center of the ribs. And then I can define how thick I want the rib. Do I want to add a draft? Do I want to add rounds to it? I have all those options built in with the tool. So the first thing I'm going to do is I'm going to select my sketching plane, and I have this datum plane that I had created to build these ribs off of. And then I'll use my trajectory rib option. You'll notice it puts me right into the sketch environment. One of the nice things about sketching the center of the ribs is I don't have to align these to my model. The rib will actually auto-extend until it touches the model. So I'm just going to go ahead and create a line. I'll just use this reference here and this reference here. And what you'll notice is that when I create this rib, that these will auto-extend through the model. So I'm going to go back to my standard orientation here, because when I finish this sketch, it's going to want to create that rib right away. Okay? Now you'll notice that my sketched entity stops right about there, so the rib auto-extended out here to the right until it hit that boss, and then it stops. Had I extended that line a little bit further, it would go right through that boss and then touch the model on the other side. And we can do that real quick by editing the internal sketch. And I'm just going to drag that out to here. And then we'll say OK again. And you can see that that rib goes through the entire model. Now the one thing about this is that we don't probably want that rib to go through this boss here. So in this case, what we would do is, again, edit the internal sketch. I'm going to drag that back to here, and then maybe add another line over on this side. And then that will achieve my desired result, is that I have the rib now that does not pass through that boss. Okay? Now we also have the option to add a draft. So for example, maybe I wanted to add 3 degrees of draft. Or maybe I want to add a fillet round at the base, or a full round at the top of the rib. Of course, all of this can be managed in the shape dialog. Okay? If we don't want a 2-tangent round at the top, we can also specify the value. For the bottom round, we can make it be the same as the top if we wanted to. So we have a lot of options here to control this shape. In this case, I'm going to turn the rounds off. Okay, so we'll say no round on the fillet. And I think what I will do is keep the round on the top at this time. Okay, so we'll say OK. Whoops. It didn't like what I did to it, so we're just going to go ahead and cancel that. It didn't like that round on the edges there. Okay, I'm going to go ahead and redefine that. And the reason I want to do that is I really don't like the way I created the sketch. If I edit this rib, you see I have these dimensions here that really don't go anywhere. So that really bothers me when it comes to making a drawing. I've got extra dimensions in my model that I would never put on a drawing. And also, it opens up the rib for failures, all right, because we have these dimensions now. If I change the size of my model and the rib ends up outside, it will fail. So in this case, let's go ahead and edit the definition of this. We're going to edit the sketch. Select my sketching plane. We'll sketch. In this case, I'm just going to delete everything here. And I'm going to recreate this, but I want to reference some geometry. So I selected to create a line. And during the creation of the line, if I use my Alt key, I can actually select references on the fly. All right. So now I have these references that I can snap my geometry to. So in this case, we'll create the line across to here. We'll create another one from here to here, and then another one from here to here. Okay. Now, what you'll notice in this situation is I have no dimensions for this rib. That's what I like. So we'll say OK, and there is the finished product for that rib. Okay. Now let's talk about the Autoround feature. Autoround is a tool that will round all the sharp edges on the model if I choose to do so. I have some options within this Autoround tool to control what's actually being rounded. So the first options I have are to create the convex edge rounds or the concave edge rounds. Okay? I can choose one or the other, and I can even make the radiuses be the same if I wanted to do that. Okay? For the scope, I'm going to use solid geometry, that's by default, or I can pick the edges that I want to round. Well, that kind of defeats the purpose of an auto round, but what it does is it sometimes will create the round better than if I were to pick the edges for a regular type round. I don't have any quilts or surfaces in my model, so therefore that is not available. I also have the option to exclude if I don't want to put rounds on some of the edges. Okay, so for example, I might not want that entire outside loop or that entire inside loop. Everything else I might want to have the round on. Okay, under options, I have a few things really to create a group rather than a single round. Now I can actually change this after the fact. I can select the round in the tree and turn it into a group. So I'm not going to select this for now. Let's see what we got here. If I say OK, we've got the round. Okay. Now what you'll notice is that all the sharp edges, both concave and convex, got rounded except for the edges that I excluded, which were these top two edges here. So as you can see, we've got rounds pretty much all over this model. Okay. Now, in reality, I probably wouldn't have done it this way. I probably would have just rounded the inside because it's probably going to be a plastic molded part, and my outside rounds might be something different. Okay, so I'll edit the definition of this. And I'm going to say, just give me the concave edges. And there we go. Just the inside now, concave edges got rounded as part of that feature. So very quickly, if I'm creating plastic injection molded parts, I can create a series of ribs very quickly using the trajectory rib, and then I can round the entire inside of the cavity in one shot. So very handy tools for creating these plastic injection type molded parts very quickly. Okay, at this point, let's talk about drafts, chamfers, and shells. So in this case, I'm going to just back up a little bit in my model to this part of the model. First thing I want to do is create a draft on this part. Now when we select these surfaces to be drafted, it's always a good idea to use the most robust selection method, that being a seed surface selection in this case. So to select a seed surface selection, what we have to do first is select a feature, and then if we move our cursor slightly, the next surface highlights. We'll select that surface. That is now my seed surface. And then holding down the Shift key, I'm going to select one edge of that seed surface to identify the loop of surfaces that I want to collect. Now in this case, I want to select something that is the least likely entity to change in this model. And for me, I'm going to say that's this edge right here. And so by selecting that edge, you can see that I've got all the external surfaces that I want to add draft to. So I've already selected those surfaces. I'm going to go ahead and pick my draft tool, and then I just need to select a draft hinge. And then all of those surfaces are now being drafted. Okay? Now the beauty of this, the way I selected it, is if that shape were to change, it will still get drafted. Okay? So very robust method of creating the draft. Okay? I'm going to go ahead and remove this hinge, and I'm going to select a new one, which will be this plane here. And the hinge in this case, let's look at the back of this model. In this case, you can see that the hinge is where this datum plane that I selected passes through the model. So that's the pivot of this draft now. Okay? What's nice about this is if I wanted to, I could actually split it at the hinge. And now I have two-side draft. Okay? In this case, I got the entire model drafted in one shot. Okay? I'm going to cancel this because I want to do it again. I want to show you another selection technique. Right? We're going to go ahead and do almost the same thing. I'm going to pick this feature. I'm going to move my cursor slightly, and then I'm going to pick my seed edge. And now I'm going to hold my control key, and I'm going to deselect that end surface. So now what's included in my seed are just all the outside surfaces except for that one. Let's go ahead and create the draft. I'm going to use this rib datum plane as my hinge. I'm going to split it at the hinge. And then I'm going to enter in my two values. We'll say it's 5 at the top and 3 at the bottom. Okay? I like what I see here. I'll go ahead and accept that. So I've got all those sides drafted except for this one end. Now I'm going to go ahead and put a draft on that. But I'm going to do something special. Okay? We're going to draft on that. We're going to select this surface as our hinge. And I'm going to use the split by an object. And in this case, I can either select a sketched curve or I can actually define it right here on the fly. And that's what I'm going to do. I'm going to sketch on that surface. I'm going to select some references here. I want to use this bottom surface as a reference. So we'll go ahead and select that and go back to the sketching plane. And now I'm also going to make this a symmetrical sketch. So I'm going to use the center line to imply symmetry. And then we're just going to create a couple lines here. There's one symmetric line. There's two symmetric lines. And then we're just going to connect the dots here. Okay? So that is now my sketch for my split. We'll go ahead back to the draft dialog now, or draft dashboard. And we're going to rotate this around so we can see what's happening here. I've got draft on one side, and I've got draft on the other side of that sketched shape. And so here we'll say that that might be 10, and at the bottom might be 5. Okay? I like what I see there. We'll accept that. So that's the finished product for creating those drafts. Now there's a lot of draft options, too many to go into for this call. So I recommend that you read up on your own. There's a lot of resources out there. We'll go through some of the links in a few minutes here. The next thing I want to do is a chamfer. So I'm going to go ahead and back up again to this extrude, and we're going to create a chamfer. Now chamfers behave a lot like rounds behave today, meaning we have multiple sets, we can manage the transitions, and so on. So I'll go ahead and create a chamfer here, and I'm going to select this edge right here. Or what's better is if I use my pick from list and I use my intent. That says give me all of those at once, and therefore if the shape changes again, I'm not going to lose my chamfer. So we'll say OK there, and we've got one chamfer. We'll specify some value here, maybe 0.25. Now I'm going to go to sets. I'm going to say give me a new set. And in this case, I'm going to pick this edge and my control key and this edge, and we're going to make this one just a little bit larger. We'll say it's 0.375, right? Now the reason I'm doing both of these chamfers in one feature is I have the ability now to manage the transitions, okay? So what I mean by that is we have our transitions icon here. We're going to switch to transition mode, and now I can determine how I want this transition to look. So if I pick that transition, I can now say, well, I want that to be a patch. And you can see that that looks a lot different than if I had just the chamfers intersecting. Or I can say, give me a corner plane. In this case, that's what that looks like. So we have these options to specify what we want that transition to look like. I like the patch in this case. I'll accept that. And that's what we have. Okay? And I could have managed all these transitions if I wanted to. Now I want to show you something a little bit special about transitions that you may not be aware that you can do with transition. And that's actually stopping the chamfer at a particular reference. So we'll go ahead and edit the definition of that chamfer. I'm going to go to my sets, and I'm just going to remove that second set. Okay? I'm actually going to remove the first set too because I want to remove some of the references. In this case, we're just going to pick this reference here again. And you'll notice it didn't include this other edge because I didn't use my intent selection. But this is actually using a rule that we can view under the details. If we go to details, we go to rule-based, you can see that tangent is the default rule, and that's why it selected all those edges. Okay. Now, what's really neat about this is I have transitions at the end. I'm going to go ahead, though, and I'm going to create a datum point for my transition to stop. I'm going to do that right now as part of this feature. So we have our datums option in the upper right-hand corner. Let's go ahead and select a datum point. I'm going to pick that edge, okay, and let's see what our options are. We have the ability to put on the edge the point, or we can say a ratio or real value, or we can reference something. In this case, I'm going to reference that surface and specify that point is going to be 1.5 from that surface. We'll go ahead and create another point on this edge. I'll reference that surface again, and we'll specify the value at, let's say, 0.5. Okay, so I have 2 points that I've created that we can see if we turn our points on that we're going to use to stop that chamfer. So I'll go back to the chamfer dashboard. We'll hit play. I'm going to turn on my transitions. I'm going to select this first transition, and we're going to say stop at reference, and we'll pick that point. I'm going to select the next transition, and we'll use stop at reference again, and I'll pick that point. So now we have a chamfer that is actually being stopped by those points, And then we can come in here maybe later and add a round in here. I want just a little round to finish that off. We'll say it's 0.062. And then we'll select that edge there as another option. Okay? And there we have the round on those chamfers where they terminate. Whoops. Okay. The last thing I want to talk about is shells. And then we'll open up for some questions. So I'm going to go ahead and back up again in my model. And then we're going to use the shell tool. The nice thing about shells now is we can actually shell a closed volume. We don't have to remove any surfaces. So we can actually shell a sphere today, where in previous versions of Creo, Wildfire, or Pro-E, we were not able to. Okay? So in this case, I just need to specify my thickness. What do I want that to be? And then select the references that I want to exclude from the shell. Okay? And I can exclude as many as I need. What's also nice is I have the option to enter a non-default thickness. So if I select that, I can pick maybe the bottom and give it its own thickness for the shell. Okay, so very handy tools now available in the shelling tool, and they've been around for a while, but they certainly help creating these shell models much easier and more robust having these options available to us. Okay, we can also exclude surfaces from the shell. We can use some surface extensions, and we can also tell to prevent shells from penetrating the solid at a particular location. With that being said, there's my shell. So with that, I want to open up for some questions. We'll go back to our slideshow, and we're going to go with some questions. And to enter questions, all you need to do is in your dialog for the GoToMeeting, there is a chat box at the bottom of the tool. If you'll just enter your questions in the chat box, I will try to answer them as best possible. So I'll go ahead and pause for a few minutes while any of you would like to ask a question. Okay, I don't see any questions coming up in the GoToMeeting dialog, so we have just a few more slides to go through here. First of all, we have some helpful links. And this presentation is being recorded. You can review it later if you'd like. But we have some links that you might want to investigate. First of all, our resource center at TriStar. We have all of our originally broadcast live webinars covering a broad range of topics in depth, and they're all done by TriStar application engineers such as myself. PTC has a website called the Learning Exchange, which has free videos covering many aspects of PTC software. And these range anywhere from 2 to 10 minutes, but there are several hundred, if not thousands, of videos for you to review. For things like creating draft, or trajectory ribs, or shells, things like that. There's also the support page, or the support portal at ptc.com, where you can read up on knowledge articles and suggested techniques for using the tools. And of course, the details for enhancements to the tool can be found at the PTC release notes page. Also, PTC has begun offering subscription offers rather than perpetual licenses for your Creo tools. You can save 50% when you update. And there's top four reasons for considering the subscription-based service rather than a perpetual is that it's always up to date. You have access to the latest PTC Creo versions. You can also take advantage of the PTC Creo capabilities not available to perpetual licensed customers. Your budget is predictable. You're always going to know what it's going to cost you. And it's flexible. You only have to subscribe to what you need and when you need it. And for more details, you can visit the TriStar page for products PTC Creo and transforming your PTC Creo license. In the future, we have a few webinars already scheduled. Please go to www.tristar.com in the Events tab, and you can see what events are planned in the future. And we'll be adding more of these, and we'd also like to collect your feedback for topics that you might like to see in more depth or that we haven't covered. So please feel free to let us know. Contact your account manager if you would like. Let him know what you want to see, and they'll forward that message to us. So with that, thank you very much. Again, my name is Shawn Schreckengost. I'm a Business Development Manager and Application Engineer with TriStar. Have a great day, everybody. Thank you.